Hey, everybody. Good to see you here. We got Tiffany, Catherine, Mohammed, Tiffany, Carly, Shivam, and Roderick. Good to see everyone here. Let's see. Mewbot, you awake right now? Let's re-wake up Mewbot. Let's go at some points. We got a first question right here. Does this sound correct? A correlation of 0.02 indicates a strong positive association. I put false. What would be a strong, who knows in the chat right now, what would be a strong correlation? We're doing some basic questions here to start out. What is a strong correlation? A correlation that is strong, things we should know for all concepts. This had some lunch real quick here. Here, sure. Like I ate some yogurt, had some more coffee. What would be a strong correlation? We'll be going over a lot of stuff here today, it looks like. What would be a strong correlation? I think Mewbot's awake now. Will be a strong correlation of one is correct. The mom and I need to go to live chat right here. One is strong, but what's also strong? Correlations. Here, we'll talk about correlation here for a second. We'll start off with some correlation. Good stuff to start out with. One is strong. That is correct. Let's go take a look. A little bit on correlation right here for Stat 201. One is a strong correlation. One is one of the strongest correlations, and one looks like this. I got to be careful how I draw it because one should be perfectly on the line. One is perfect positive. You're thinking statistically significant. So something that is statistically significant would be below 0.05 p-value. So correlation is values of R. Correlation is values of R. So R stands for correlation, at least in statistics. And one is very strong. One is very strong. One is as strong as it gets. But there's another one that's just as strong as one. One that is as strong as one, and correlation measures linear strength right here. These are great concepts for all statistics. Oh, Kayla, this will be the next chapter, so don't worry, Kayla. We're going to do tons more questions right here. This is the next chapter, the last chapter on the test. I want that little blinky thing to go away. It's not going to. Wait, if I do this. There we go. This is the last chapter on the test. So this is for Stats 1, last chapter on the test. A correlation just as strong. But these have different what? 1 and -1 have the same strength, but they have a different what? Oh, no worries. This one's a little bit easier. So if you're wanting the concepts right here, 1, -1 have the same strength, but they have different what? Here's the ways we describe this. Strength, direction, form, and unusual features. So those have different, they have the same strength, which is the absolute value of the correlation. If you take the absolute value of correlation, you'll find its strength. Kind of, they have a different slope, which is the direction. Roger, great answer right there. They have a different direction. One's positive and one's negative, so they have a different direction. So they're the same strength, but they have a different direction. But when we have a weak correlation or like a residual plot, 320 stuff right here that has no relationship, a weak correlation would be closer to what value of correlation? A very weak correlation would be closer to what value? A very weak correlation would be very close to what value? A very weak correlation only would be close to 0. You have to be careful because why does this, which is super strong, why does this right here have a correlation close to 0 too? This is a good trick question. Why does that have a correlation close to 0? And remember, there's terms strength, direction, form, unusual features. So that has a correlation close to 0. So does this. This one below it has a correlation close to 0 also. Reason being, why? Why does that have a correlation close to 0? Exactly. And the form is what? Correlation is meant to measure the what strength? Great answer, Roger, right there. It doesn't follow the form. Because Kayla right there, 100 points, Kayla. Look at, you're following it right there. You're getting it. Because correlation's meant to measure linear strength, and this does not have any linear strength. It doesn't have a linear correlation to it, and so there's no linear correlation, but it still has a strong relationship. Strength is how tight it is around the form, so it has a very strong parabolic relationship. Exactly right there. Great job, Project. So this is a good venture into chapter 6 right here, knowing kind of the concepts of strength, direction, form, and unusual features. Lucky guess, worth 100 points. So remember these: strength, direction, form, unusual features. Unusual features is the only thing we didn't mention right here, and they are outliers and Tiffany. Outliers can do anything. Outliers can make a positive correlation weak, a positive correlation strong or stronger, a weak correlation strong, a weak correlation weaker. They can make positive correlations negative. When it comes to correlation, outliers, which are things that do not follow the pattern of the data, that's not how I change where the outlier is at. This would follow the pattern. The further it is away, the more of an outlier it is. So things that are outliers can do anything to it. If it's an outlier in the data set, it can do anything to the correlation. So if it says, can an outlier do this? The answer with correlation, the answer is yes. Q, straighten up. No outliers. We don't want these outliers because they can do anything. And so this has been a good kind of quick review of chapter 6 right here, which we haven't gotten to yet in 201. It'll be on Monday. We have the Canvas content due that night, and then we have the quiz due the following night. It's not a super hard chapter. Chapter 5 is the hard chapter. Not saying just skip over chapter 6, but chapter 5 is the hard chapter. Good stuff right there. Tiffany, does that make more sense? 0 outliers, 0 for outliers right there. We don't like those outliers. Let's head back to the main screen here and do another question. You got this. Really good stuff right there. Really good review of correlation. Good concepts to know, kind of some basic stat concepts. So since 0.02 is close to 0, then there would be no linear... Exactly. Since 0.02 is close to 0, there is no linear association. You can't say that there is no association, but you can say there's no linear association because that's what correlation measures. Does that make sense, Tiffany? Excellent questions right there and great work. So that does answer some of the questions like for that problem right there. Have we learned all the information for exam 1? Chapter 6 is the only one we just covered probably... I'm not lying. That's about 40-50% of chapter 6 right there. So Kayla, don't be afraid. That was literally 40-50% of chapter 6. Tiffany, how much easier is chapter 6 than chapter 5? Because Tiffany's been working on chapter 6, getting those questions done. Like how much easier is chapter 6 and chapter 5? Empirical rule stuff, I think we can. It's technically with an E. Don't worry, I can't spell. It is technically that right there. But don't worry, I can't spell. I only know it because I have to spell it every semester. If I didn't have to spell it every semester, I'd be like, I don't know how to spell that. Just wait. You'll catch a lot of typos and a lot of basic words that people should know. Usually empirical rule, so much easier. Chapter 6 is way easier. I'm gone. I'm back. Chapter 6 is way easier. Chapter 5 is where it's at. Chapter 5 is the tough stuff right here. Spelling is not fun. We have a new quote today. I'm starting with chapter 5, part 2, homework. Yes. Question 3, we can probably go at. Chat was crazy today. Muhammad has the next question. Can we go over questions 1 through 3? Muhammad, can you pick one of these? Muhammad, take your pick. I think, so which one, like, cough, cookie equals cough. Yeah, that's where I was at class yesterday. I typed cough dough instead of cookie dough. Or was that office hours? So Muhammad gets the next pick on the question. 475. So Muhammad wants to do one of those questions. Let's go take a look. Take your pick, and we'll go check that out. I'm going to go grab that up here, and then keep asking those questions. We're going to do some R coding here. R, not R correlation coding, but we're going to do some coding in R. Assignments. Muhammad, great job working ahead right here. Time series basics. Take your pick. And we shall do one of those questions. I've got the assignment up. Let's do 4 on 475. Oh my gosh, we're jumping all the way to question 4. Let's do this. And then Roger's got one coming up right here. I think next question will be... We'll go... Carly has a question here. We'll do Carly's, then Tiffany. I'm going to write this in the chat so I remember. Carly's, then Tiffany's, then Shivam, and then Roderick. So if you're looking for your question, and I need to make this thing where I can show it on the side of the screen. I need to make this. I just have to think of how to compose it. So that's the order right there we have. Tiffany, I'm just jumping yours a little bit back since we already did one. But we're going to do Carly's after this, then Tiffany's, then Shivam's, then Roderick's. We'll do a whole bunch of different stuff right here. So stay tuned as we get these done right here. Oh my gosh. Don't talk too quickly. Sorry about that, everyone. I can't talk and think. Let's go check this out. Here we go. Time to do this up. Let's do it. Okay. Here we are with 475. Question 4. Assignment. Time series. I think I called it that, didn't I? Time series basics. That's what I call it right there. You're welcome, Roger. Thank you so much. Love the positivity. 50 points out there. Everyone's so positive. Okay, here we go. Download the TUT1 CSV. So if you note right here, what's going on with this code? Oh my gosh, I'm increasing the wrong chat. What is this code doing right here? What is this code doing? Line 43 does what? Got some starter code right here. You might have to delete that view when you net. You might have to delete that view. What's going on right there with readr : read.csv? Well, first off, you better make sure you have readr. I think it loads up normally. You might want to go here and take the readr and put this at the start if it's not loaded up, just in case. Then technically, is read CSV in readr? Oh, I think I know why. No, it's right there. So what was the deal with that : right there? I didn't notice for a long time. Why do people keep doing that? Good stuff for anyone who codes in R right here. For if you're coding in R, and we should know what that means. What does that mean? You want to know what every one of your lines of code are doing. Sometimes there's a few times where I don't know what my codes are doing, and I'm like, which is bad. Like that code I had to find to get that mosaic work, I still don't understand ! Sem. I'm like, I don't know how it works or why it's doing it. And that's not good. That means I can't replicate it. I can't use it in the future. I got something working, but I wish it's like me going out and buying an engine and putting it in, but now we're creating the engine. What is that code doing? I don't know is a fine answer to give. If you say, I don't know, that's a fine answer. What does readr : read_CSV do? Read CSV is the easy one. It's going to read a CSV file. It's just going to read it for us. And this actually works. It's just going to read it. So that's reading a CSV file right there. That is reading a CSV file. But why are we doing this right here? Which we probably don't need. Why are we doing this readr : Who has any ideas on that? What's the point of that readr : If you program in R, what is that doing? Like if I go here and I go reg class ... I'm doing what? So we are using the readr function. Using the read CSV function. But when we do the name of a package and then : we can access the things inside the package without loading the package. So actually we don't need to do, I stand corrected, we don't need to load library readr because we don't need to load the library to access things inside the library. Like I could go here to Plotly and, we already have Plotly loaded. I should be able to see the Plotly package too. There it is. And now I can access functions inside of Plotly. Does that make sense right there? I also have a package called cowsay, which I don't think I have loaded, but I can go here to cowsay and I can do cowsay and I can say hello. And here's my package cowsay. And look, it's a little kitty saying hello. Does it do a random one? It's a little kitty saying hello to you right there. So it's using the functions inside the package when you do the : This is the name of the package, and then you can access things. You can access things like functions or data frames or whatever you want inside of it, because now we're using inside of the cowsay package is this. So inside of the readr package is this function. So we don't actually have to load the package, which people a lot of times do this if you want to just load one thing rather than load the whole package. They just call the function from within the package. Does that make sense right there, Mohammed, right there? That we are calling the read_CSV function, which reads CSV files. We're going to store it in here, and we are thus also pulling it from the readr package. Now, if you take a look at this right here, got a bunch of cool stuff down here. We've got here column names. We are going to the column names of the data frame we just loaded in, and we are doing what? Read what this is doing right here. We are loading in the column names, and we are doing what? So what are we doing? What does this line of code do right here? Think about it. This is very important to know when you get to this, like, read it as a sentence. Go to the column names of this, go to the blank, and store blank into blank. So just think about what it's doing step by step and be like, can you read that and understand what that's doing? That's huge. You have to be able to read it and be like, okay, we are going to the first position, and what are we doing? So we are only looking at the first position right here, and we are doing what to the first position? So you're getting it. We are going to the first position. We're saying go to the column names of this data frame, which is just the names of the variables. So if you've ever seen an Excel spreadsheet, It's just an Excel spreadsheet. We're just looking at the names of these columns and we're storing quarter into the first position. So we're going to overwrite this right here. We're going to go to that first column name and we're going to overwrite it. So if you take a look, we overwrote it. So that's what this code did right here. It went to this first column name, which is, it's no longer this. It was like a ... one or something, but we overwrote it with quarters. So that's what that code did right there. It said, find the column names, go only to the first position, overwrite that first position by storing into it with quarters. So we're storing that into first position of the column names, which is the names of the columns for the data frame. Right here, some really awesome code. Make sure you have the packages loaded up. At the start of this, we are using, if things are not working, you might not have library FPP3 loaded up. I do. So it never hurts to make sure you got your libraries loaded up. When we run this, it should run. Still got my fingers crossed. So what did we do right here? This is a lot of what we've been doing in class. This is what we saw last class. So this is a great question right here. Maybe I shouldn't have extended this assignment. I don't know. Right here, we are taking and storing something called my time series. This is the pipe now. So everything here is going to be piped. We're piping the data frame we created into a mutate, which is going to take quarter and do what to quarter by turning it into the month year function. So what is it doing to, it's taking quarter, and then what's it doing right here with the mutate? We saw this yesterday. Oh, I should have wrote a thing that said, explain what this is doing. I should have said, write an explanation. I should have put that here as a question. So what is it doing? It's going to take what was in quarter, run this function my on it. What is my? We'll find out. My right here is the month year function. It's part of Lubridate, part of the tidyverse. So we've got here the my function. Oh, look right there, my. Because when you look at the way the time series looks, the data, which we can eventually see, here's the data right here. We store something differently. We're going to pull out of here the month and the year right here, the month and the year. It's going to, well, what is going to, and you're basically right there. It's pulling out the month and the year right here of the data frame right here. It's pulling out the month and the year. So we also probably need to index this here in a moment. We do have the index right there, I'm saying. So we're going to index it by the quarter, which is the time index right there. So we're indexing it right there. It's pulling out the month and the year and kind of parsing this into a month-year way of viewing it. So when you run this right here, it's going to overwrite the quarter thing with a Lubridate version of month-year. So we can look at what it was previously a second ago. Looking at this right here, it looks a little bit different. It is in a date format, but we're just making sure it's Lubridate format now. And so now we get it in the Lubridate format, which is coherent with tidyverse or consistent with tidyverse. And now we go here, and this is going to turn it into a tibble, which we need a tisbo, time series tibble. And now we're going to take it, pass it through into the pivot longer, which is going to subtract out the quarter. We don't want to view that on here. We're going to pass it into a ggplot, which is going to do all of our beautiful graphics for us. We've got right here that the x variable is the quarter, the y variable is the value. And you know what? I'm going to look at pivot longer, because I don't think I can give enough explanation for that. Pivot longer is a function that lengthens data, increasing the number of rows and decreasing the number of columns, the inverse transformation of pivot wider. Ooh, got to read more about this function. And we're pivot longering everything but the quarters. Always look at what your code's doing. If you don't have a good answer for it, talk to that rubber ducky and say what it means. So increasing the number of rows. I'd want to see some more examples of this. Interesting stuff right here. And that's what we're doing to it right here. We're adding a line to it. I love how the geom functions work. We're just adding a line, and then the facet grid is going to add them all onto one grid. So you can see right here when we do this, they're going to be in their own separate grids. If we don't facet grid, they'll be in their own, they'll be on one graphic. So the facet grid is going to put them in separate quadrants, where the not facet grid is going to remove them, and we'll just go here to the very end of this. And what's so cool about Lubridate, I mean, they're doing it this way, is if you want, you could just go right here and hashtag out this code, and you could rerun it. And you can see the difference right here. So I hashtagged out that code, kind of keeping it there, but I wanted to end it. Here's the non-facet version, and here's the facet version. I'm going to take a better look at what pivot longer does, because that's a function I don't use nearly as much. But good stuff right here. And now what I would like to say is one thing you could do is we should be able to pass this through. And everyone knows I love to do this. I got to use my shortcuts. This is the pipe option. Oh my gosh. The pipe option right there. And ggplotly. I love some ggplotly. Oh, it's mad. ggplotly, it says no. Apply to an object with this class right here. Really? Well, the answer is we can't pass it through unless we can do it with the facet grid. I'm really disappointed. That's weird. Certain things don't like the ggplotly. And this looks to be one of them. It's mad about it. It's saying, no, you can't do that. You can't put this into a plotly object, but you can view it this way. That's so weird. We'll pass it through here into object X. I'm going to try just one more time on this. And that stores this graphic into object X. It's probably just going to get mad at me again with the ggplotly of it. I'm surprised because it is a plotly. Really? Oh, I know why. Because it was trying to pass the facet grid through. We had the same thing happen during class right there, but it was trying to pass the facet grid through. And once again, I just want to point out how easy it is to make some really nice graphics. You're going to run into some errors because I run into some errors too, but we've really got some nice graphics right here that we can work with. Is this making sense, Mohammed, what we're doing, especially with the piping option? You just kind of want to practice your piping option. We could use the pipe, and we did this in class. This is exactly what we did. If we did want to use the pipe over here for this, we'd have to take all of this, and this would have to evaluate, and then we would have to pipe it through. So I was trying to pass through the facet, not the graphic that was made, and now it's mad again. Does it really want the pivot longer on that? Well, let's find out the hard way. Let's have all that evaluate. Oh, it's mad about it. It's mad. Well, that's where you just say, well, we got it working one way. Yeah, I'm shocked. Well, that's where you say, okay, we'll just store that as X, and then we'll ggplot the X. And you know what? I think, frankly, sometimes it might be better to not have the facet grid. But you want to, so good so far, awesome. I might like it better like this if we did this. It all depends. It's all preference. And this is what I love about this is you can go and remove and change things and view things and zoom in. Really great graphics right here at pretty easy to make. So just knowing what you can do to change this around is very key. So briefly explaining your patterns you see in the data. So when you look at this right here, some of these are pretty stable. Some of these are pretty stable when it comes to it. Like if you were to talk about some of these processes here that are pretty consistent, yeah, I'm just showing you right there maybe. Some of these processes have a little bit of irregularities in it. Maybe they have seasonal trends. We're looking here at the quarters. You could even zoom in with the ggplotly. Now you can't knit the ggplotly. So you can see what's going on here over a certain period of time frame. And just kind of seeing what you see. And the key thing is just to talk about it. Just think about how you can talk about this and how you can explain this. So think about going through, and I don't want to like explain this totally, but I mean, look at this. Like this is the end of the quarter. So that's the very end of the year. That's the start of the year. If you see right here, that's 3, 6, 9, 12, 3, 6. And then, oh, we missed the 9 in here. Oh, 12, 9. Oh, I miss it. 12, 3, 6. Oh, it's a little bit weird in here. 9. Just think about how to describe this. Is the 3 at the top again? The 3's at the top there. There we go. Look at that. There we go. There. Now we're on the roller coaster. Ooh, I like this roller coaster. Whee! Whee! That's pretty consistent. There's 9. That's also 9, but this one's not. Yeah. You know what's really cool? Should be able to do this. Should be able to do this. Let's check it out. We got the different values right here. Let me look at my time series. So we've got here the GDP. We got the sales. And should like that. It's mad about that. It's mad, it's mad, it's mad. We'll come back and look at that. But think about what you have right here with the seasonality and stuff like that. Like, I don't want to say the answers, but is this making more sense, Mohammed, right here, what to do with this code? Not too crazy of a question. Worth 10 points. just kind of talking about what you see and what you have going on right here. That's the biggest thing, is you want to talk about it, you want to explain it and go through it, show the graphics, give some interpretation. How would you explain this to someone if they couldn't see it? A little bit of a stat to one question here, like how would you explain this to someone who can't see the graphic? How's that looking? How's that sound right there, Mohammed? Pretty good. Just going through, explaining what you see. And I want to point something out. Plotly objects do not knit. You could screenshot this if you wanted. You could screenshot this, but you cannot knit it. It will not knit into a Word document. We don't turn in HTML, but that will not knit right there. So if you want a screenshot of this, that looks really nice. I'm not going to grab the end right there. I do like this right here, and you could also change the name thing on there. Name works. But you could take a screenshot of this and insert it into your Word document. You could also put the fastest back on if you want, but just depends. I think it looks really nice, really clean, good graphic right there, but you can't knit that into a Word document because you can't have the interactive feature in the Word document. It's HTML code, and the HTML can't go into a Word document. So that's got it right there. Good stuff. Good review of this question. Just make sure to explain what's going on right here, and make sure to give full words. What do you see? What's going on? Examine it. The better you explain it and the better you point out things you're noticing as you hover over it, as you look through the data points. And I really think the Plotly can allow you to really get an idea of what's going on. If you go through here and you say like, oh, where are the peaks right here? What's going on with the peaks right here, which is more consistent? Which of them looks to be more irregular? Kind of dropping some hints right here about what's going on. Also, you've got differences in the means. I mean, that's something huge to point out. Oh, that's, yeah. Mohammed, last question right here. Literally, we're talking about shape, center, spread. Are you going to work? We're talking... It's mad. It does that every once in a while. I don't know why. Probably besides the patterns in the data, you can see that there's much different means, like low mean, medium mean, high mean, low variation, medium variation, high variation. We're literally talking about the idea of like shape, center, spread right here, because we have right here the center of the distributions are quite different and the spreads of the distributions are quite different. Does that make sense, Mohammed? Like, these are big things to mention, is that some of these processes, like the sales process, has in it more variation with a much higher mean. So it really goes back to Stat 201. Stat 201, if you're listening, shape, center, spread right here is very important because we want to understand those distributions of this. And guess what? I'm thinking, I wonder how these look. I'm thinking they might look pretty, not quarter. It's the only one I want to look at. It's bimodal, interesting. Interestingly enough, it's bimodal. I don't know if that loaded up. 1 second. Library GG pubr. There it is right there. And let's pass this through into ggplotly. And here it is right here. So this is an interactive histogram showing us the counts. All this good stuff. Histograms, last question of the day right here, worth 100 points, not of the day. But histograms display how many what variables? This is a question we should all know. Whenever we make a histogram, they display how many what variables. I promise you these concepts to you, Smith and it. Yes. You'd have to take a picture of the ggplotly. You can't knit a ggplotly. You'd have to get it, take a picture, and then just upload the picture into the Word document afterwards. So you'd have to do that, which you can do. And then you could store it into your thing, like as a knitted thing. Histograms display how many what variables. All my classes should know this, because we're even using it here in 475 for a second. Because we have to know how to make a histogram. Histograms display how many what variables. Last question right here with 100 points. Histograms display how many what variables. Every class should know this. Then we got Carly's question next, I think. Does anyone know? Histograms display how many what variables? They're over there on the top. Histograms display one quantitative variable. One quantitative variable. And that's what we have inside of here. The sales is a one quantitative. They display one quantitative. Mohammed right there, good shout out to it. Mosaic plots and contingency tables display two categoricals. So here's your two categorical zone right here, where I'm currently over. Mosaic plots, contingency tables, stacked bar charts, side-by-side pie charts all display two categorical variables. Very important graphic to know. Helps with all sorts of visualizations and know what you're doing when. So this can really help right here with these topics. Good stuff to know for all classes. Good stuff. Let's head back here. Carly's question is next. Let's do it. Next question from Carly. Carly's question was Chapter 5, Part 2, the homework question 3. Got it. Homework question 3. Homework stays the same, but if you ever have a quiz question, make sure to put part of the quiz question on here because the quiz questions change. The quiz questions change. They'll be different at all times. You never know what quiz questions you'll get. You'll find out when you take the quiz. Chapter 5, Part 2, number 3 on the homework, coming up right here on Stat 201. Here we go. Chapter 5, Part 2 homework. Replace questions. Question 3. Pulling up in the background right here. Oh, one of my favorite questions of all time. We got this right here. I'm going to get this looking perfect. Give me 2 seconds. Okay. Awesome. Let's check this out. Time to ace this question. Here we go, Carly. Check it out. Chapter 5, Part 2. Percentages on the normal curve. Let's check it out. So I actually have to vanish off the screen for this. Now, what we need to do is we need to go to the David M. Lane applet. That's what you see on the side of my screen right there is the David M. Lane applet. This is the David M. Lane applet. If you want to find areas above a number, you'd go here. Areas below a number, you'd go here. This will be very important for Chapter 5, Part 2, and you need to know how to use it. You can also find percentages, or put in the percentage, and find the area above or below a certain number where that percentage would be. This is the top 20%. This is the bottom 20%. It's always going to be in the same z-score, but we could change the context. Just knowing how to use this applet is what you want to know for the test. You won't use the applet, but you'll get pictures. Take a look at the Canvas content questions we've been doing to see what a test question might look like, where it shows you the picture and then you have to solve for the answer. So take a look at that. Those are good examples of how you might have to use this on the test. So our question right here gives us z-scores. Z-scores always have a mean of 0 and a standard deviation of 1. The applet broke. Happens sometimes. Z-scores always have a mean of 0 and a standard deviation of 1. We want the area above 1.55, which means we need to go to 1.55, which is going to be on this side of the curve, and plot above it. So when we do this right here, we go above 1.55, and the area is 6.06%. We're going to take that and copy it. We're going to check the answer for this one. And then we're going to go down to here, and we're going to put in the answer of 6.06. It wants to 2 decimals. Zoom out just a tiny bit right there so you can see it all. Make sure your picture over here looks just like your picture over here, and then check your number is the same number down here. And it wants it as a percent, so you have to times it by 100. We should get the right answer, and we do. The next one says a z-score and the area below 1.2. 1.2 is going to be over here a little bit, so it's going to be below here. And so let's go below 1.2, and we get the following. So we need to find a graphic that looks like this. And this is the graphic here that looks like this. Looks just like it. We're good to go. Check our answer, and we got it. The area is going to be this number down here, and this is the percent of observations that are expected to be below a z-score of 1.2. So there we go. Make sure your decimals are proper. That's 88.49% of the curve right there. A lot of the curve is below a z-score of 1.2. Next, we want to go between negative 1.7 and 1. That's what the z-score is between. That's how this is read right here. I know, Kayla, right? You're like, wait, this got way easier. That's why I say, like, swing by office hours and we'll check it out, because here's the answer number 3, and I bet you can't guess where answer number 4 is going to be. Here's number 3. Number 3 is going between negative 1.7 to 1, and take a look. Your graphic looks like this. Your answer looks like this. You got it. Now go ahead and copy paste that answer over here, and make sure your decimals are proper, and you should be getting a lot of the curve. If you were to put something like 7%, yes, Kayla, that's it. Tell everyone. Be like, practice, practice, practice. Kayla, 100 points right there. The practice that makes perfect. Next, we want a z-score, and this one looks weird, but it's saying the absolute value of the z-score is greater than 1.15. So that's saying we want a z-score outside of this. So we want a z-score outside of this. So this is the absolute value of the z-score is outside of this. And this is almost exactly 25%. You know what, Ma Pearson, this one goes to you. Now, be very careful. Once again, we matched the graphic. We looked at the graphic. We looked here. This is a z-score in absolute value is greater than 1.15. Like if you had -2 absolute value is greater than 1.15. So it's things that are greater than an absolute value of 1.15. And this would qualify down here on the negative side. Now, we're going to be like this. Now, don't be very careful. You can get a little bit of wiggle room on these answers. You want to be very, very careful because if you don't put in enough decimals, you will lose points. I took a risk there by not putting in that 0.01, but I do know these questions have a little bit of forgiving nature to them. But Carla and it was also Carla also, right? Carly, making some more sense on how to do this. The good news about this question right here is it goes first question, second question, third question, fourth question, and you can make sure your answers are the same. Make sure whatever you see on the screen, if you're doing the second question right here, you see the same graphic. Carly, amazing work. 50 points, Carly, right there. This one, once you see how to do this one, it's a little bit easier. And it's one of those ones like, yeah, I got this. I got this. You know what we're going to do? We're going to do my favorite thing in the world. This is Brian. This goes out to Brian right here. Then we're going to do another question. We're going to do this question, but without the applet. So here we got to reload it. This is us doing this question without the applet. What grade can we get with no applet? The reason I do this is because I want to show you that you can get good estimates with the empirical rule. So knowing the empirical rule right here, I know that, look how bad I am. I'm horrible at this. I know that it's area above, not below. I know that this area has to be between 16 and 2.5, and it's going to be a little bit more than, it's going to be between 5 and 10%. So I'm going to say 6.78%. Oh, I'm wrong. 6.5848%. No. 98%. Oh, it's 8%. I was off by 1%. Pretty close. That's close. Oh, less than 2. We got this. Less than 2 is going to be over here. This is one of the ones we can use the empirical rule on. Now, our numbers on the empirical rule are pretty close to this. Can we use just our exact number right there? It's mad. That's because it is basically 97.5, but it's 90. The exact amount, if you use the applet, so I'm going to cheat because I know exact amount, is 94.449. And that's the exact amount. 100 minus that. 100 minus that. Divide by 2. The 100 minus. Oh my gosh. Wow. There we go. That's the exact answer. This is called Brian has worked these problems a little bit too much. Really? What am I doing wrong? Find the percentage left of a z-score of 2. This is Brian trying to have a little bit of fun right here. 2.5 is above there. Oh my gosh. Okay, wait. So it's 90. Oh, 95. I think I typed 94. 95.449 is what's between there. So 100 minus that. Divide by 2. Copy that. And 100 minus that. There it is. That's going to be the exact answer. It's called I've done these questions a little bit too much, and that's the right answer. So we've got that. Okay, here we go. The area between these numbers, this is super difficult, but I think I can get a good guess. The area between these numbers is going to be that. This is very, very close to, it's going to be a little bit more than 80%. It's going to be a little bit more than 80%. Little bit more than 80%. Got it. There, we got that one by guessing. A z-score outside of the absolute value of 1 and -1. So that has to be a little bit less than 16%, but more than, no, a little bit less than 32, but more than 20. And it falls off pretty quickly. This is a tough one to guess. 27.55. 27.33. It's just a gamble right here. You're just in a, I just moved slightly trying to gamble. We got it. So we just did this quiz, guessing it. We did this question, and we got all but, did we get all but one question? We just guessed this quiz right here without the applet. So that's one of the reasons I like the empirical rule, is I was able to get almost all the questions. The only one I missed was this one right here, and I was off by 1%. Now, once again, go to your applet and do the area above 1.4. So if you go to the applet you have and you go to a z-score and you go to the area above 1.4, go back here to your z-score and go to the area above 1.4 and you're going to get the exact answer. So once again, I'm just doing it to practice to make sure I can get decent guesses and I know how the curve works. But I love getting 100 on that. If we have time later, we'll come back to it. But that's one of my favorite questions. It's a lot of fun. I just like guessing games. So we'll check that out later. Let's go back to the main screen. Good practice right there. Practice, use the curve. And then if you want to get really good, try to see if you can get that question without using the curve to like how close you get. If you understand how the percentages work, then you'll understand kind of what your numbers should be close to, which is good when you're doing like multiple choice questions. The next person here, that was Carly's question. We have Tiffany's question, then show them next. Tiffany's question is, yes. Tiffany's also wondering about standardizing the units. Standardizing the units will not make correlation 0 because correlation is based on z-scores. So correlation is based on z-scores. So standardizing units won't do anything to correlation because they're based on z-scores. So we already standardized them anyways. So you will not change correlation at all if you standardize the units. So to Tiffany's question, correlation does nothing. Standardizing variables does nothing to correlation. Timing them by a constant does nothing to correlation. Changing from feet to inches does nothing to correlation. Correlation is unitless, so it doesn't matter what unit we measure the correlation in. If I measure how fast you run in seconds or hours, you'll still have the same correlation to how much time you spent working out before your run. So your speed at which you run would be correlated to how much time you spend working out, no matter the way we measure those variables, like in hours, in minutes, and seconds. It's still gonna have the same correlation for the same data set. Next question was, good question, Tiffany, right there. Shivam said, I think Shivam's next. Yep, here we go. So I need help on the Canvas content quiz. The question about body temperatures higher than 99.26. I think we might have a version of that one. Higher than 99.26. Here we go. Let's take a look. It's going to be Canvas content. Body temperatures higher than 99.26. Canvas content quiz. Chapter 5. Let's take a look. Madison, you bet. We'll do that here in a moment. You got it. I think there's one more ahead of this. You got it, Madison. Great time to ask a question. Let's do this. Canvas content quiz, Chapter 5. Body temperatures. So let's take a look on this curve right here. What percent of area is Brian highlighting? Use the information above and tell me. Brian is highlighting what percent of area right here? Use the information above and tell me. What percent of area is Brian highlighting on the curve? So I like doing it the other way. Well, yeah, we'll do this. What percent of area has Brian highlighted on the curve? Use the information above and tell me what percent of area has Brian highlighted on the curve. So all of that area right there I've highlighted in red is what percent of area? And this is what we want to make sure we see when we're doing our questions. Be like, okay, that is this percent of area right here. So use the information above. And what percent of area have we highlighted? It's the Socratic method. I got to ask those questions. So there's some points out there. Get everyone going. What percent of area have we highlighted? 13, not quite, very close, Madison. So this is where, because a lot of people say, well, how would we know this? Great question, Madison. I'm throwing another 50 points. This is going to tell you the answer for the area outside of it. So this is where you wouldn't know it off the top of your head. It's going to tell you that that's 13%. Does that make sense, Madison? You wouldn't know that normally. It's just telling you that outside of these numbers right here, outside of 99.26 and 97.14, outside of that, which we're showing down here, is 13%. Now, here's what's interesting. What do you notice about this area? And watch this. What do you notice about this area here? And also this area over here? What do you notice about these two areas? Great job, Madison, right there. And what do you notice about this? This area over here and this area over here. They're the same. So wait a minute. You're on it. You got it right here. You're getting it. if they're the same size, and we could confirm this by finding z-scores and such. They won't always be the same size, but they are for this one. Yeah, outliers can do anything, Tiffany. Outliers can do anything to correlation. Outliers are like superstars, so not that they do anything to correlation. They equal 0.13 together. Kayla, you're on the right track. Keep going, Kayla, with that line of thought. We want to find this area right here. We're trying to figure out how much is this area. So Kayla, you're on the right track. You're right there. You just like a step away. You're just going to turn around and see the answer and be like, whoa, that's the answer. We want to find that area right there. Kayla, take it away for us right here with another 50 points. Explain what we need to do next. You're just right there at the answer right now. Because when you said they will equal 0.13 together, they're the same. They're the same. So they equal that together. So what's that worth? You're right there, Kayla. You're right there. I think you're going to be like, boom, Madison, teamwork makes the dream work. Throw Madison, everyone 100 points right there. Madison, you're very correct. It's 0.065 because together they're this. And that's not what's in the center. That's not what's in the center. Together they're 13%. So you would just simply divide that in half. Does that make sense, Madison? And everyone, great work. Does it make sense how to do this one right here? So since you know it's the same thing on both sides, you can say, well, then above that is this. A tougher question would be like, it's not like super tough, but if you want to make it more difficult, you could say, change this right here to lower. So now it's a little bit more difficult, but with the work we've done, what percent would be lower? So I just made a different version of the question, but what percent would be lower? This is a different version, like a slightly more difficult with another step. What percent would have temperatures lower than this? And here I'll shade it in so you can see it. Shading it in right here. I'm just removing the shading on that. What percent would have lower? This is just another version of the question. Like another way that a question could look on the exam. So what percent would have lower? Good, like additional, just be like, okay, could we find that? I'm basically showing the answer by highlighting it right there. Just think if you know 6.5% is above there, then you could find out how much have lower than that. Since you know how much is above there now. What is the shaded area, Kayla? Don't worry. Great job, Kayla. Don't worry. What is the shaded area on the graphic right now? What percent of body temperature is expected? What percent of the time would we expect a body temperature to be lower than 99.26? What percent of the time would we expect a body temperature to be lower than 99.26? Well, that... Not quite, Madison. Good try there, Madison. Good try. Not 74%. So think about this. And this is a good question then. Don't worry. Good questions is when we make mistakes and then we practice. If we know that this over here is 6.5%, then how could we get the remaining portion over here? Hint, the whole curve is equal to 1 or 100%. So if we look at the whole curve, it's 100%. And so we won't subtract. This is just the point at which we have right there. I see what you... No worries right there, Kayla. That is the temperature. This is the percent of area. So this is the percent of area right here. You're on the right track. You're on the right track. And this is the amount of area because that's just the temperature of the individual. This is the percent of people who have a temperature above that. So that, which I crossed out, is the temperature of the people. This is the percent that have a temperature above. No, Kayla, don't worry. Kayla, 50 points. Great. This is, you have to put those answers out there just to practice. So don't worry. You're doing the right thing right here. I think you got it now. That is the percent of area above this. So what is the percent of area below this? You're on the right track with the mathematics you did. You're on the right track with the mathematics you did. So do the same mathematics, and then you'll get it. Because you know the area above it, so we just say, well, that's the area below it if we just subtract from 100. You got it. I know you got it. Some more extra credit here. Take some deep breaths. I'll answer here in a second, but I want to see someone get it. It's a good test question. We just basically turned this into another test question. So these numbers right here will equal up to 1. This plus, like, it's the whole curve. Yeah, it's Kayla. Great job right there. Yeah, you got it. Perfect answer. Yep. I think, would you turn... Yeah, and then you could do both ways right there. Either which way. Great job right there. Excellent work. Either which way you want to do it. Great job, Madison and Kayla working together right there. It's 6.5%, or you subtract that from 100, 93.5%, or 0.065, subtract from 100, or subtract from 1. Just make sure if you have it as a decimal, you subtract from 1. If you have a percent, you subtract from percent. Does that make sense that this is 100% of the curve now shaded in? But that's got it. Excellent work. I think the next question goes out to Roderick. I think that's the next question. Let's check it out right here, and then we're going to come back. Madison, your question is next after this. And everyone, correct me if I ever go out of order on the questions. This was Shivam's question, then Roderick. So Madison, your question is next after this. Great job. Excellent work. I'm just throwing another 50 points. I like going crazy on points. That's what we do here. Hop back to the main screen. Excellent work, everybody, right there. Great job. Let's check out Roderick. Can you put your question in the chat again as I get the assignment loaded up? I could scroll through, but we're going to do work together right here. I'm going to go get the assignment. The function assignment. I think you wanted function 1, right? If I'm pulling from memory. There's a lot in my memory right now. It just falls out. So I think you wanted the first assignment right here, or the first question on homework 3. I'm downloading the RMD. I'm downloading some apples. Waffles. I like waffles. Great job, Madison and Kayla. Excellent work. It's all the practice. And then I try to show like the best ways to solve stuff, because there's some like ways of solving stuff that's like, not the best. And I think we're doing question 1. So correct me if I'm wrong. This is homework 3 for 474. Question 1, homework 3, 474. 320 if you swing by, we'll do everything. Wait, gotta repeat that because I look at these videos. Question 1 for homework 3, 474. Let's do this. Question 1 for 474, homework 3. Now, what I always do is when I go back and mark the videos, it helps me to have that, because then I can go right to where I do this change of scene and then I can see what it is. So I gotta make sure to help out future Brian. So set up an if-else statement. Kind of like Excel right here. If you're in 201, this is like Excel right here. Have you ever done a little Excel? Some Excel right here. Define a variable x to be positive if the num is 0 or more, and negative if 0 or less. So it wants to use an if-else. I like an if-else, not an if-else. So what? If is a what? If is a what? I don't know. 474, 475, are you in here? 320, are you in here? Because I might try to answer more things. If no one's here to answer questions, I might not be able to ask questions. Who's here for 320, 474, 475? Who codes? Because you'll know if is a function. If is a function. Awesome. I did the if else, yeah. So if is a function that takes a condition and then runs code. This code will return high. This code will return nothing. This code will return what? What will this code return and why? We'll make it like all Perta here right here. No, don't want to do that. There, I like that. Yeah, we'll do that. It's so short that I might not do this, but it looks fine. What will this code return? What will this code return? Be very careful how you space things out and make sure it runs. This one, Madeline, I love it right there, Madeline. It won't return high, though. Madeline, thank you so much. That's 100 points for taking just taking a shot. I don't care. I'm in that 100 points button again. I can't appreciate it enough when people just take a shot at it and say, you know what? I think it's going to do this, but don't worry. It's going to do something different. It's going to say bye. And why did it say bye this time? Why? And so, Roderick, why did it say bye? Remember, how about this? Now it says hi. Let's say this. Now we're just explaining. So if runs when there is a true. So guess what it says? If runs when there is a true. And if we put a false inside of here, else runs when there is a false. Does that make sense? I know Madeline, and thank you so much, Madeline. I was like, I just like when people say, like, take a shot, and that was definitely worth the points. Does it make more sense that what is ever inside of the if, else runs when there is a false in the if? So if runs when there is a true in the if. So we could go right here and we can put a false. What about when you need to do a by? That would be like a sequence. So we're just seeing right here how this works. Like bullet point 3. Oh, we'll get to that here in a second. We'll get to that. So this is what we got right here. So think about this. We've got right here a number. Question 4. Yeah, Madison, we should be able to. Yep. I think we got was that your question, Madison? I think Madison's is next, right? I think yours is next, right? I think it is. I'll double check. So define a vector x to be positive if num is 0 and negative. So now we're going to go right here to the true code. Let's go to num. And let's put in 1. If num is what? If num is what? Look at what it says right there. Awesome, Madison, you got it. Yeah, well, that's why we have 2 Madisons. I was like, yep, so Madison and Madison. I'm going to put MP, then MH. There we go, right there. So that's our next order right there. I know, right? I was like, I swear. Thank you so much right there. So what do we want to do right here, Roderick? We want to do if num what? If num what? If num what? If the num is what? There's a few ways to code this. Because this is our condition. If num is what? If num is what? We're just looking at this right here. Less than 0. So if num is less than 0, then what do we want? I just deleted something. What do we want this to run? This is the true part. This is the true part. What do we want it to say? What do we want this to say if num is less than 0? If num is less than 0, we want it to say what? This is the true part. If num is less than 0, it'll run this code right here. So what should this do? It should say what? If num is less than 0, it's going to say this. It's going to tell us this right here. And we're going to store this into x. It says, we're going to store this into x. Well, if num is less than 0, we want to say negative, because that's the true portion of the code. And then this is the false portion of the code. If num is not less than 0, this will run. And let's check. And what should x be right now? What should x have in it right now? There's the code that ran. What if we've done this correctly, what will x have in it right now? And so what will x have in it right now if we've done this correctly? And I think we have. Will it? But will it though? Look at what num is. It should have positive. If I've done it correctly. Yes, I've done it correctly.
Wow.
I was worried. I was like, maybe I don't see something. Define a variable x to be tiny if the num is between -8 and 8, inclusive, and huge otherwise. Okay? So let's insert a chunk right here. I like doing my work where I can see it and see the question. That's the insert chunk button, puts the code in there. So now we're just going to take basically the same thing right here, and let's check this out. So if the num needs to be what? The num needs to be what? Tell me the first condition. I'll do the second. You could do %i and %. I probably wouldn't, because then you wouldn't get your whole numbers. You could do it. If you're doing whole numbers, that works. That would be... I don't like it because it's not whole numbers. I mean, it would be whole numbers. You'd have to do vector -8 to 8. I'm probably going to have this evaluate. That could be a condition, but I don't love it because it's whole numbers. It should run the save into... Oh, I'm just doing that to test it out. Always test your code. Always test your code. So good question right there, Edgar. 50 points. I'm just writing it to test my code to see if it works, because anytime I code something, I'm going to be like, does that work? I'm going to trial run. I'm going to beta test it. So right here, I'm going to say I want num to be less than 8 is a value between, okay, less than or equal to 8. If num is less than or equal to 8, tell me what to put right there. Yeah. Be very careful on this sign. Greater than or equal to -8. Okay, so the sign right here is going to be very important. I'm going to space this out a little bit more. So what do we need right here? This is where your thing could get very bad. The wrong sign right here is going to make a mistake. Yeah, it's just mad about not having a sign right now. I'm going to put this in its own evaluation. I'm going to put this... We don't probably need those, but I like to. But for the actual problem, we need something to num. Yep. You would need to set something right here for it to run. Great question right there, Edgar. Yep. If you want to run this function, you need to put in a value of num. So what do we want between this? We want the value to be less than or equal to 8. The value needs to be greater than or equal to... We don't want an or because if you look at it mathematically here, I'll show you. The or would do the following on a number line. If you say the or, here's 8, so you'd get all these values. And then the other thing you're selecting is all these values. So if you do the or, you will get every value. Does that make sense? Because you're saying it can be less than or equal to 8, or it can be greater than or equal to -8. But what we want, Mohammed, great job right there, is we want to do the and, so it must meet both these conditions. So does that make sense right here? I think towards later on, Edgar, it's going to have you set values. We're testing our code out. Does that make sense, Edgar? So make sure to be testing your code as you run it. Number one way to make sure the code runs is to test it out. So I just put in values to test what num is to make sure it works. There's no, at this point, it's not telling you to do a certain num. I think it does later on. But I'm gonna use values to make sure my code's working. I'm gonna be like, is this code doing what I want it to do? So we want to use the and right here to have it meet both conditions. And by having the and right here, we go right here. And now, if it meets both conditions, what should this say? If it meets both conditions, what should we do right here? Does the and do all numbers within? It must meet both conditions. So for this code to run right here, which is inside the if, for this code to run, to store into X, it must meet this condition and meet this condition. And we want it to say negative this time because we're going to say it must be less than or equal to 8, and also it must be greater than or equal to -8. So this one will be what? Towards the end, definitely, Timmy. I think we'll have time here towards the end. Yep, I'll try to take a look right here. So this will do what? Oh, after office hours. Yeah, definitely, of course. This will say, what do we want this to say? And remember, the process is what matters here. Okay, so if both these conditions evaluate to true, then we want it to say what for the code? We want it to store into X this. So if both of these evaluate to true, then we want it to evaluate to what? We want it to store into X what? Tiny, yep. And let's test it. What should X print right now? What should X evaluate to right now? If we're working this properly, what should X evaluate to right now? What should X evaluate to right now if this is correctly running? Look at what num is, and what should be stored into X if this is correctly running. So if we have done this correctly, X should have what stored into it? If this is correctly written, X will have what stored into it? Tiny. And it does. We can go here and check 9, and it runs. We can check -9, and it runs. We can check. So that should be huge. Does that make sense? And if we check 8, because it's inclusive, then we still get tiny. And if we check -8, we still get tiny. So it works right there on everything right there. Does that make sense what is going on? That it is evaluating and putting out the right values, inclusive of -8 and 8, and saying that these values are tiny, and saying the other values are huge. I think number 3, and we might jump over to another thing here in a second. We got a similar sort of thing right here. Define defines defines a variable x to equal a small even if num is an even number from -6 to 6 inclusive and not small even otherwise. So this is where it gets a little bit confusing because we basically have the same conditions. It's very, very similar, but we have an additional condition here to deal with. So we can almost take our same code, change this right here a tiny bit, little bits. And we're going to change these numbers to 6 and -6. We're going to let this evaluate right here. And this is the hard condition, which actually I think was in your last assignment. We want num, when we look at the what, well, let's do an and, because we also want this to be true. Where's my and? Oh my gosh. Wow, I'm blind. We also want this condition to be true right here, that when we take num and we look at its remainder of 2, this remainder of 2 should be what? When we do the remainder of num with 2, its remainder should be what? So when we look at the remainder of num divided by 2, if it is even, that remainder of num when we divide it by 2, because right now -8 is in there, so the remainder of that, kind of the answer, right? So this right here, if we have an even number, the remainder would be 0. So we want it to have a remainder of 0. The percent tells you the remainder of a value when you divide it by the other value. So what is this right here? Kind of last question right here. What is the answer to what the code is on the bottom of the screen for 50 points? So what is that going to evaluate to on the bottom of the screen? The code I have on the bottom of the screen evaluates to what right now? And the way it would be read is, if you divide 8 by 5, what is the remainder? And the remainder is 3, because you can divide into it one time, because it goes in one time, but then you'll be left over with 3. It's like the leftover right here. So that is looking at what is left over. So think about this. When we divide our number by 2, we want there to be what? We don't want there to be any left over. Does that make sense? And if there's nothing left over, then the value is even. So the only way to have 2 go into it evenly is for it to be even. So now if this is true, we want it to say small even. If it meets all of these conditions, we'll have small even. And if it doesn't meet all these conditions, we will have not small even. So right now we should see not small even. That is correct right there. And we do have inclusive of those values, right? Let me double check. Inclusive. So this should evaluate to small even. Good. If we do something like -5, we should get not small even. Is this making sense how this code is working? All of these conditions must be met inside of the if. And I've done a lot of spacing inside of here to make it very clear what we're evaluating, that we have these conditions of what it's contained between evaluate, and then we have this condition right here to check to see what the remainder is evaluate. I did some extra spacing because R reads through spaces, so I can make it look a little bit nicer to read. So I can see like where are my conditions at, and then you see on the next line right here the code that evaluates, and then we've connected the else right here because the else will only run when the if statement evaluates to false. So whatever is inside of here is a singular true or singular false. You only get one true out of this or one false, and then the code will run the false statement if you get false, or if you have a true, it'll run the true portion, but we have a longer, much longer code inside of here. Is this making a bit more sense? We're gonna hop back to 201 here, but how are we doing on this question 1 right here? We've done a good bit of it, but kind of walking through the steps is very important right here. So what I always hope is people go through these steps, practice coding it, try doing it without this video, and make sure you know how to code it, and you could do these steps right here, because it can be pretty quick. Let's do one more real quick. This one sounds crazy. Let's do it real quick. Define, just to show you that if we know the steps, define a variable x to be extraordinary if num is evenly divisible by 2, 3, or 5. So what we want to do right here is we want to go here, and it needs to be evenly divisible by 2, 3, or 5. And the or is key in this. So let's put a num right here for practice. We're just going to do this one quick. Why not? Num right here, 4. And we want to go num %% 4. And we want to go equals 0. That is if it's evenly divisible by this. And the answer is it is evenly divisible by 4, but we don't want 4, we want 2. And then we want to see, or, there's the or for the pipe, or, and let's go right here, 3 or 5. There's our thing, and it is true that it is divisible by one of those numbers. When numbers equal 0, then blah, 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 blah. For example, okay, yeah. Well, that's it. From here, the percent is the divisible, what the remainder is. So, and that's kind of the condition for that one. Just throw inside of an if and an else, and you're good to go. So Roderick, what would the following code? So don't answer too quickly if you know the answer. What does the following code give us? We're gonna do 2 quick questions, and we'll hop back to 201 right here. What does the following code on line 59 give us? It says, when you divide by 12 by 5, what is the leftover undivisible part that does not go into it evenly? Like the remainder, that's what a remainder is that this would go into 12 2 times evenly, but then there's going to be a remainder of this, as in this portion would not go into it evenly. So if you divide 12 by 5, there will be a remainder, as in the uneven portion by which we cannot divide 5 into 12 into an even amount of times, because it goes into it twice, and then there's a remainder of what? So it's what is the remainder of 12 you can divide it by 5. So I think you go 5, 10, and then you'd have a remainder of what? You'd go 5, 10, and then you'd have a remainder of what on this? Yep, that's it. So what's this going to be? Rapid fire questions right here. What's that going to be? So that's, you'd go 5, 10, and then you have a remainder of what? So it just says when you divide 14 by 5, there's going to be a remainder of what when you do this? Yep. And then think about this. What's this going to be? 5, 10, 15. So what's the remainder of 15 when you divide it by 5? What is left over? 0. Yep. And then by doing this right here, we're just saying, does it have a remainder of 0? And the answer is true. So if number was 15, we'd be running the same code right here, and we'd say that there is no remainder. So this is saying, what is the remainder of the number, which is 15, when we divide it by 5? And the answer is, it is true that there is no remainder, because the remainder is equal to 0. So good questions right there. Let's do some 201. Ow, got me. Madison's question was, I'm putting a little chill music right here. I'm putting my sad chill music. Down music. First question was from, great questions, MP. Okay, let me see. Madison Potts asked, I think we got time for just both of these. We got it. I'm scrolling back up to find it. That's where I got taken copy. Can we do question 4 on chapter 5, part 2 homework? Yep. Let's do it. Chapter 4, part, there we go. We already got part of that up. Oh, yes, continue. Wow, just in time. Here we go. Let me get the applet going up. This is going to be a good one. You're going to like this, because our practice with the applet is going to help us a ton. So let's do the weights of steers right here on chapter 5, part 2, homework, question number 4, stat 201. What's up, Finch? Good to see you here. We're doing a little chapter 5, part 2, homework for question 4. So whenever you get the normal model right here for these questions, you want to either draw it out for the test. Remember how we talk about all the time, we're like, draw it out. So you want to draw it out. We got a crazy drawing right there. But for when you're doing it online, not for the test, you can easily draw it out with the following. Now, I always put it in both of these because I might have to use both. It just helps to take a moment. P is out of the range. I don't want to. What? Chill out, applet. Oh, we broke it. If you break it, reload it. We're just putting in the values. Make sure to not type letters. It doesn't like that. And we're going to, sorry. I put that in the area, I think. We're just putting in the mean, which is the center of the curve. You see it over here. And the standard deviation is the units by which we go up and down each time. And this one it gives us the percentage, which means we are going to get the value from an area. So it's telling us the area. This 10% right here, the highest 10%, which we almost have. We could go straight to that. The highest 10% is going to be right here. Good to see you here, Brianna. Good to see everyone. Extra credit. So we have here the highest 10% on the curve. This is the highest 10%, but I want to point out also, the highest 10% is also known as the what? Take a second and pause right here while Brian inputs his answer. The highest 10% is also known as the what? Look at the screen and tell me. The highest 10% is also known as the what? The highest 10% is also known as the what? This is where the highest 10% is. It's also known as the blank this. The highest 10%, which we covered this a lot in class today, and if you're in class later, we'll be doing this too. The highest 10% is also known as the what? Where the highest 10% is. It's also known as this. So what is this? The highest 10% is also where the what is. It's the same location. I'll show you again. Here's the highest 10% over here. But this is the same spot. If I just do this right here, you're looking at the exact same answer. It's the 90th percentile. Madison, great job right there. Some extra credit. Madison, you're right. And Brianna, you are right. That's the practice we need. So when we hear the highest 10%, we can also know that that is the 90th percentile. You'd like to be in the 90th percentile or even 99th percentile. That'd be great. The lowest 20% is going to be down here. We could show it a lot of different ways by going to like the top 80, which is a really weird way to talk about it. It's much better to do the bottom 20%. Remember, our percentiles go from left to right. Percentiles go from left to right. These are the lower percentiles. This is the 50th percentile. And these are the upper percentiles. Over here is the very highest part of the curve, the higher percentiles. So we're just going to take our answer right here and copy paste it down to 1 decimal, and we got it. The middle 40%, we can go right here to the between, and we can get the middle 40. There's a lot of ways to get this, especially because you could just ask for the lower 30 and the upper 30. It'd be pretty complicated, so we probably don't want to do that. That's going to round to 1114, and that's going to round to 1202. So if you were in the 93rd percentile, if you were in the 93%, you'd be the 93rd. Exactly. If you're at the 93, great answer, Finch, right there, some 50 points. If someone says you're at the 90, you're 93% or 93% or below you, you are the 93rd percentile. That's exactly right there. Great stuff. How's this question looking, Madison? Much like sometimes when people see it, they're like, oh, I got that. And then just make sure you know what you're looking at. So I think some of these questions are a lot easier when you see how to work the applets, and then you practice reading the pictures, and you get to the exam, and hopefully it's good. That is so much easier than I thought. I know, right? And then people are going to be working this late at night and be like, I don't get this. This makes no sense. And you're like, come to office hours. Great job, Madison. Let's hop back to the main screen. We got another one. Yeah, it's some of them are easier than you think. Some of them are harder than you think. It's amazing. It's just knowing how to read the applet, knowing how to look at the pictures, and understanding what it's showing to you. So we did a lot. If you're in class later today, we're about to do some harder questions later. We have class at 1:50, right? We do. The other question from Madison is grabbing the second question from Madison. Oh yes. Slept like 8 hours last night. Maybe I'm sleeping too much. I never thought I'd have that problem. Madison, can you repost your question? Minor seminar during class. Oh, that's all right. No worries. No worries. Yeah, we got it recorded. You'll be there mentally. I like that, Finch, right there. No worries, Finch. We have it recorded, so you can check it out later. I'm looking for the other Madison's question. Thank you so much, everyone, for being here. I'm a different Madison. I love that. Okay, we're shooting here. Can you please go over Q4? Which one is that, Madison H? Madison H, which one is that? Because the quiz is different every time. I say so, but what exactly does the question say? So if you can tell me part of the question, like the questions about like steer weights, IQs. We got 9 minutes. We might have time for something quick after this, Kayla. Feel free to drop it in the chat. We'll see what we can do. We might give like a speed run of it. You never know. Always drop those questions. I'll try to do as much as we can. Do I have 2 things open with that much? I don't. But drop the question in the chat. We'll see what we get to. The question is, what percent of stamina number curve found in each reason? We did that one earlier. I think it's my favorite one. So we're going to go check that one out again. Madison, or Kayla, drop the question in the chat. We're going back to my favorite question here. Woo! I really do love this question. I'm not joking. You say, Brian, you're crazy. And I say, you bet. Crazy for statistics is what I am. I hear people be like, stats is no fun. I'm like, it's data. Data's fun. Oh, yeah, let's take a look. We're going to check this out. Quiz question, homework question. Kayla, drop your question. We probably have just enough time. This is a really good practice question here. Let's do it. Wrong button. What did I do? Clicking buttons. So this is chapter 5, part 2, the percent of normal curves. And Brianna says, no fun right here. But you know what makes it really fun? The applet. The applet is a great way to solve these problems and understand what it's showing you. Now, you won't have the applet on the test. You might get pictures on the test. Here's an example of what a test question can look like. Oh, empirical rule speedrun? Might have just enough time for that. So here's a picture of what the applet looks like. Here's a picture of what you might see on the test, and here's how to solve questions. We did a Canvas content earlier. What I highly suggest doing when you get to the test is drawing out your curve and adding as much information to it as you can. So if you're given a problem with a mean and standard deviation, you can then plug in the numbers and find out the answers to the question. So without it, we would have to give you pictures. Now, z-scores are going to be standardized numbers that are the same anywhere on the curve. So you see right here a z-score of 0, 1, 2, 3, -1, -2, -3, which is how many standard deviations something is above or below the mean. That's what a z-score is. When we do this, we want to ask questions like, what percent of area is above? What percent of area is below? What percent of area is between or outside? Above, below, between, or outside. To reiterate, above, below, between, or outside. Hint, hint, hint. Hint, hint, hint. It follows the pattern. So beyond knowing the kind of cheat for this question, which really helps out, make sure you know what it's showing you. As in, when we want to look at the area above 1.3, well, 1.3 would be on the right side of the curve, and we want the area above 1.3, so it's going to be over there. Now, I love guessing these because if you know some extra numbers on the empirical rule, you can get really close, and I think we might get it. Oh, no! That's got to be close. Oh, we got one last try here. We're guessing, you know what we're going to say? Let's get it correct. It's 9.68. And look at that. We got it wrong by that little. No, you can't see it because it's behind me. This will give you the exact numbers. Is this making sense right here, Madison, that this is going to give you the exact? But I always like taking guesses at this to see how close I can get if I guess it, to see if I kind of understand what this area would be close to. You don't need to guess it. We'll go back and start it over again. You don't need to guess it. It's just a good practice. 0.7 is a lot harder, but you can get the answer to 0.7 very quickly by finding the area above it. And make sure your graphic matches. This graphic matches. And here's the area right here. This area is going to be 24.2%. Make sure your decimal is in the right spot. And this has the answer right here for the area above a z-score of 0.7. For the next one, we want the area less than 1.95. Now, 1.95 is a pretty magical number for anyone who does a lot of statistics. It's very close to 2. And by being very close to 2, if you know the empirical rule, my gosh, below. Sorry about that. Brain jumped a moment there. The area below, once again, I repeat at that start. By being very close to 2, we want the area below 2, and the area below 2 is very close to 9.75. If you don't know that, check with the applet. You're not meant to memorize these things. Check, and I think we're close enough this time. Get up. See, we're not close enough. That's why we have the applet. It wants very exact answers right here. Once again, is this making sense, Madison, right here? I did an earlier version of this. I try to work it differently if I work it a second time. But I'm showing that I can get a good estimate with the empirical rule. My guess of 97.5 was a guess from the empirical rule, which is good for the test. The next one right here wants the area between. And so I just want you to think, I'm not going to answer this for you, but between -2 and 2 is how much area? Between -2 and 2 is how much area? Who knows the area on the normal curve between -2 and 2? And this is a good review of the empirical rule. What is the area between -2 and 2? Between -2 and 2 is how much area on the empirical rule? So these are the empirical rule numbers we should know. So we want to go between -2 and 2. So we could put in the numbers here. Between -2 and 2, according to the empirical rule, is how much area? And this is not quite -2 and 2. It's a little bit less than that. 95. So would you agree with me this should be a little bit less than 95%? So if it's going to be a little bit less than 95%, I'm going to say 93.55%. And we were wrong. I'm going to say 93.88%. And I am wrong. And then we say, let's get the right answer right here. Negative 0.85 to 2 is 94.51. And look, we were very close. Not close enough to get it by guessing, but it was a little bit less than 95. I should have went really just a little bit less than 95, because between negative 2 and 2 is 95 according to the empirical rule. This one says the area outside of a z-score of 1.5. So outside of 1.5 is going to be this right here in absolute value. So outside of the absolute value of 1.5 is right here, because negative 2 would be greater in absolute value than 1.5, and 2 would be greater in absolute value than 1.5. This one's a tricky one. To guess this one, watch this be the only one I get. It's going to be between 20 and 10%, but much closer to 10%. So like 13 point, something like that. This is a very tough one to guess because it's in a very tough region. Wow, and we got it. Literally, we get the last one by guessing it. Yeah, so we got it. And just once again showing you that you can get the exact answers by going here. And we were very close. We were close enough that it gave it to us. We were only off by a few thousandths there, but it's about 13%. And that's why we know the empirical rule, because we can get good guesses on this. We can be like, well, it's got to be a little bit less than 16%, between 16 and 2.5, and we can kind of get some good, or 32 and 2.5 rather. But I know some additional numbers that people don't know because I've been doing this for way too long. Not in a bad way. But Kayla, let me drop this in the chat right here. To Kayla's final question, if you want review, wrong review, review 1. So for those wanting to review this, because these concepts only come with practice, and we don't have enough time for a speedrun right now, but here's what I want you to check out, Kayla. Go to this page that Mubot's going to put in the chat, and the number one way to practice this stuff is I do have a speedrun video on the page right now with me going through the empirical rule numbers where I plot them all out. I'll even drop this link in the chat. But if you go right here to empirical rule numbers, our knowledge right here with our speed run beginning right now, a speed run. So this should be it right there. Let's check. Oh, I just left. Here, Brian, double hold on. So we go through here, and I think I plot out the whole curve. So we're getting all the numbers: 68, 95, 99.7. Do I not do the rest of them? But we do a problem right there, and check it out. I can't see that. Let me go grab the chat real quick. Chat time. But check that out. That's going to be a lot of help right there. Oh, did we already? Oh, that's the wrong stream. I was like, everyone already left. But that's got it. That's going to be a big help right there. 7 people watching. Thank you if you're still here right now. Oh, there we go. But check out that speed run. I'm going to start getting ready for class here real quick. But go to this page. Check out the videos, medium hair length, Brian, practice tests, all this good stuff right here. It really just comes down to practice. Make sure you are practicing, because the test is going to be like, if you see something for the first time, you're like, normal probability plot? What's that? We're going to learn it today. Coming up here, you know about those normal probability plots? Mubot and Puppet Shark. Everyone's here, but we're out, everybody. Great class today, great office hours. I'll see you in class if it's about to happen. Bye for now, everyone. Bye.